Math 26B. Let's see, I made homework for you. And it's 2 sections of homework. They're both due next Saturday. 6.5. Okay. Oh yeah, happy Friday. I hope to catch up on a lot of things this weekend, including grading and the gradebook. But today's goal is just to try to start chapter 7. And I think we're going to cover 7.1 in this meeting. Okay, let's go. 7.1. Let's see, this class does not have any quizzes, and we are just going to do notes for a while till we take exam 2. And just keep on doing some homework. I'll have more homework soon. Okay, so let's see. This is for the integration of, I'm going to say, the product of functions, or often used for the product of functions. Okay, taking the derivative of f times g. Hang on, are we doing this? Okay, the integral of f times g is f prime g plus g prime f. Okay, we know this one. Yeah, that's the product rule from last semester. F prime g at g prime f. Okay, so we take this and integrate both sides. So the integral of the derivative will undo each other. So here is f times g. This we're integrating. So f prime g, the integral of f prime g plus the integral of g prime f. All right, it's not a lot going on. I think I want to subtract this integral from both sides. Let me make sure. The integral of g times f prime. Yeah, that one. It's going to flip this around though. G times f prime. And this integral is still sitting here. I'm just going to write the integral of f times g prime. thus, we're just rewriting this statement here, but starting on this side, the integral of f times g prime is equal to fg minus the integral of g f prime. So we'll take integrals that look like this and do some scratch work to get this kind of setup. What will help is to call, let's see, we call where we're going to let u equal f of x. Du is f prime of x dx. Or like take the derivative of both sides, and then you can get to this formula. V we will call g of x. And then take the derivative of this to get dv equals g prime of x dx. And that way, when you put all of these pieces into this here, we will have the integral of u times, let's see, dv is equal to uv minus the integral of v du. All right, one more note, and then we'll just do a lot of examples. So note. You want to choose u to be a function that gets easier with taking derivatives. To be the function. Starting with number one. It is the integral of x times e to the x dx. X we will call u. And dv will equal e to the x dx. Okay, so it needs a little practice where you remember to take derivatives of u and then integrate dv to get v. So this side take a derivative, this side do an integral. Du will equal 1 times dx. Integrate both sides to get v equal to e to the x. Side note, you would put a plus c right here, but we're going to put plus c at the very end. So that's going to be a habit we use from now on. We're going to put that plus c at the end. Okay. So have this integral equal to u times v subtract the integral of v dv, the integral of v du. So we'll kind of draw this every time. Go here to here, and then the integral of this times this. Okay. X times e to the x minus the integral of e to the x dx. Okay, x, e to the x, subtract. The integral of e to the x is e to the x, and now we add c. So we have the integral of x squared times the cosine of pi x dx. Okay, this is going to be u, this is going to be dv. Oh, let's see, someone asked a question, what does the last word say? Like, here? Let me see. I don't know if it's this part, but. Okay, oh, sorry, okay. Let's go ahead and derivative of this side, get the derivative will be du dx equal to 2x. So we'll have a 2x times dx. The integral of this side has a u sub of pi x. So what we'll get is v equal to negative 1 over pi times sine of x, sine of pi x. Negative sine of pi x. Got that right. Oh, it's not negative. Derivative of sine is cosine. That's better. We go u times v, subtract the integral of v du. Here times here, minus this integral. X squared over pi times the sine of pi x. Integral of sine of pi x over pi times 2x dx. I think this is just a U sub. Let me peek. We have, oh, another integration by parts. Okay, so going to use U and dv. You could use other letters, but just kind of the style I have to let U be the function that gets easier with taking the derivative. And actually we'll bring 2 pi in front of the integral. So the number we'll bring out. So that's 2 pi. Sine of pi x times x dx. U will equal x. Okay, this is not so bad. dv is sine of pi x dx. Okay, this side do the derivative to get du equal to dx. This side integrate. So v equals the negative cosine of pi x divided by pi. It's another like u sub. Cool. And then this times this, subtract this integral across. Okay, so this integral is equal to, put it all together on the side. All right, we had x squared sine of pi x over pi. Subtract. Well, we have the 2 pi that we brought out. I'm going to cross with getting x times the negative cosine of x pi x over pi. And then subtract the integral of negative cosine of pi x over pi dx. So I'm just going to go ahead and put that as a plus. Integral cosine pi x over pi dx. Oh. Okay, let's do this. I think now all we do is simplify. Oh, this integral, and then simplify our answer. So here's another u sub. We're going to have this be the sine is cosine. Cosine goes to negative sine, and then it's, let's see. We're going to just work this out right now. So minus sine of pi x over pi squared. Okay. I'm going to add c at the end. I distributed the negative 2 pi and then added c. So we're almost done. The first piece being x squared sine of pi x over pi plus 2x cosine pi x over pi squared. Plus 2 sine pi x over pi cubed. And then plus c. Okay. The next one doesn't require so many steps. We're just doing the integral of ln of x. So we'll take the integral of ln of x dx and let u equal ln of x and dv equals dx. This side, do a derivative. Du will equal 1 over x dx. Okay. This side, integrate. V is equal to x. That's it. Then we go across and over. U times v is ln of x times x. Subtract the integral of v du. So we've got an integral of x times 1 over x dx. This would be the integral of 1 dx. Let's put this x first. So we've got x ln of x minus x plus c. So the next problem is going to need a lot of scratch work. I've seen it in the math lab a few times, but I actually don't plan to put this on the test. So I'm going to make a note to myself that this is probably not on the test, but still it's good practice. Okay, we're going to try doing integral of e to the x cosine of x dx. We let u equal e to the x, dv is going to be cosine of x dx. When you do the derivative of e to the x, you get e to the x. And when we integrate this side, v will be sine of x. Go across and over this way. Our problem is e to the x cosine of x. Is e to the x times sine of x, and then subtract. The integral of sine of x times e to the x dx. So what I want to mention is neither of our choices for functions get easier with taking derivatives. Like the derivative of e to the x is to e to the x, and we keep getting e to the x each derivative. With derivatives of cosine, you'll get sine or cosine, and you keep going. So what we'll do is we'll find a place where we get matching integrals, stop, use the integral, finish the problem. Okay, so we don't have matching integrals yet. We'll do another integration by parts on this piece. So for that integral, we will let u equal e to the x. dv is sine of x dx. So the derivative will give you du equal to e to the x dx. Here I do an integral of both sides to have v equal to negative cosine of x. Check it. Yes. Sweet. Okay, so we're going to subtract this integral. So in parentheses, all of this will be this times this minus this integral. Okay, so back to the problem. Wherever you left off on that integral, we have it equal to, let's see, e to the x, sine of x, subtract. E to the x times negative cosine of x. Minus negative cosine of x. E to the x dx. So we'll take care of a lot of these minus signs. This one's a minus, which we're going to just put in as a plus. I'll take this and distribute it here and there. Okay, so if you're taking notes, start a new expression where you have the original problem, the integral we had started with.
Professor, I didn't get a chance to see that last part. Your screen.
You didn't see. Let me see. Try writing again.
Kind of frozen, but I would just see after we changed.
Okay. Let me go. I'll go through it a little bit again. Yeah, we'll just one more time. Okay. E to the x. E to the x. Integral e to the x. This one difference. Okay, so I'll just redo this scratch work for that integral. We have scratch work. U equal to e to the x. dB is sine x dx. Okay, derivative. And this is an integral. And so for just this piece here, we're going to go here times here and subtract this. All right, e to the x times negative cosine of x. We're going to do negative e to the x cosine x. We're going to subtract the integral of this times this, and we need to have to subtract this negative number, so I'm going to put plus. Integral cosine x e to the x. So we'll do that part where I wanted to rewrite everything after taking care of the negative sign. So distribute that and get a positive. Let's go plus e to the x cosine of x minus. Okay, so from here, integration by parts. On here, we did integration by parts. And then simplified. And now I want to rewrite this part right next to this part so it's clear what's going to happen next. It's equal to e to the x sine of x. Add e to the x cosine of x. And then minus cosine x e to the x dx, which matches that first part. So what we will do is leave this integral how it is and add the integral to both sides. So I'm going to add the integral of cosine x e to the x dx on here and here. All right, so this plus this, we have two of them, so 2 times the integral of e to the x cosine of x dx is equal to just this part now, because that negative integral and positive integral adds up to 0. Actually, we're going to go ahead and erase. This was 2 times that integral. And what's left here is e to the x sine x, e to the x cosine x. Almost done. We were solving for just this part of the problem, so divide both sides by 2, and we will have the answer. I'm going to put e to the x sine x over 2 plus e to the x cosine x over 2. You could rewrite this though if you want to. So again, I think those are interesting problems, but we won't put that kind of question on the test. Any questions or concerns about integration by parts? Okay. We have a new problem. Oh, actually, one last thing. We want to add c, some number c at the end. That's better. And we're done. So we will do the integral of sine inverse of x, or inverse sine of x. We let u be sine inverse of x, and dv will be equal to dx. This side du will equal 1 over root of, let's see, I think 1 minus x squared. And we have a dx. Yeah. Integrate this side and get v equal to x. And this integral will equal u times v, and then subtract the integral of v du. X times sine inverse x. Subtract integral of this times this. X over the root of 1 minus x squared. Dx. This one needs a u sub, or we've used u already, so we could do something like a w sub. Say w equals 1 minus x squared. The derivative with respect to x as negative 2x. So we'll have this multiplied on both sides, dx equal to negative 1 over 2x dw. So I'll put this piece in right here. This will just sit where it is for now. And this is a root of w. So I've got this guy. Minus the integral of x over root w. Dx is dw over negative 2x. So x over x will reduce to 1. This negative and a negative will make it a positive integral. And I'm also going to bring out the 2 in the denominator. Root w is a w with 1/2 power, and I would like to put it in the numerator. So w as a negative 1/2 power dw. And I guess we'll remember to replace w later. Copy that part. Let's work on this integral. We're going to add 1 to get a positive 1/2 power, and then dividing by that 1/2. Make it a 2w to the 1/2. Check this out. Oops. Oh, we're doing this correctly so far. Let me know if you see any mistakes, but I think I just did a little, I forgot a negative
So the
sign.
two, so the 2w raised to the half, isn't that taking the derivative?
Yeah, thank you.
Yeah, you're supposed to be taking the integral.
Yes, 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 yes. So we are subtracting 1. Thank you. So it's a negative 3/2 as the power.
And then 2/2 in the, wait.
And then divide by, thank you, you are helping. Negative.
Oh, no problem. So since it's a negative half in the front, we're adding 1. Would it be positive half
Positive.
if we're adding 1 to that instead of 3/2?
Yeah. Let's see if we did this the other way, like do the derivative, it would be this 1/2 over 1/2 gets us to w, and then it's a -1. That's good. I think this is right. Thank you. Okay, so now this is times 2, or actually like 1/2 over 1/2 is going to reduce to 1. And we'll put in what w was. So last part. Add 1 minus x squared. This looks correct to me. I forgot a negative sign when I did it on my own, but as a class, we've got the correct solution. I've got one more example for sure. Oh, we're actually out of time. Oops. So we'll come back and do one more example later. I will make homework for this section, but we're practically done working through integration by parts. So let's see you for now. Okay. Have a good weekend, everyone.